Coming to nilpotent matrix, right? So nilpotent matrix, the definition goes something like this. First of all, it is also a square matrix, right? And the working rule for this is a power m is equal to 0. In fact, what do you mean by 0? What I mean by 0 is basically a null matrix, right? So if m is least positive integer, right? So m has to be least positive integer such that a power m equal to 0, then I can say that okay, m is basically the index of the nilpotent matrix A. So m is the index of this nilpotent matrix. So let me just explain you what all of this means. So you just take up a matrix and you can keep multiplying that to itself any number of times. So for example, if I multiply to it twice and I get a 0, right? If I get a 0, that means all the elements will actually become 0, whatever they are. Then I can say that 2 is the index of this nilpotent matrix. So first of all, why is it called nilpotent? Because some ordered product of it is 0, right? So this m can be 1, 2, 3. So for example, if you multiply them twice, like if you multiply it to itself, then you might not get a 0. But if you multiply it again, if you bring one more, then you might get a 0. Then the index will turn out to be 3. And then no matter how many times you multiply, you still keep getting a 0, right? So it will be a nilpotent matrix. But what is the index of this nilpotent matrix? The first time when I got a 0, right? So when I take this, if I got it 0 in the first multiplication itself, then m is equal to 2 and the index is 2. If I didn't get it in the first iteration and then I had to multiply again and then I got a 0, then okay, fine. If no matter how many times I keep multiplying, I'll still keep getting a 0. But this 3 was basically m was 3, and 3 was the least positive integer which gave you the 0 for the first time. So 3 was the index of this nilpotent matrix, right? That's all that the understanding is required for you. So with this, we complete all the special matrices that we had to study, both from the exam and from the understanding point of view, as far as our syllabus is concerned. Now we'll move on to understanding what adjoint of a matrix is, and that will be followed by inverse. And these two are extremely important algebraic operations because most of the applications that we will be dealing with as far as matrices are concerned. So I would just like to draw your attention back to why we were studying matrices. It was processing of data, right? Processing of data, solving equations, solving a lot of equations at the same time. All of this was simply some applications of matrices that we were concerned with. So for most of the applications that are valid for our syllabus, we need to know adjoint and inverse, the two operations that are to follow.